So in the last video we have seen the analytical determination of velocity and acceleration of the piston of a reciprocating engine or a slider crank mechanism. So let us just solve a problem on this, a very simple problem on this. If the crank and connecting rod are 150 millimeter and 600 millimeter long respectively, and the crank rotation at a constant speed of 100 rpm, determine velocity and acceleration of piston and angular velocity and angular acceleration of connecting rod. The angle which the crank makes with the inner dead center IDC is 30 degrees. So using the formulas which we have derived in the last video, we are going to solve this problem. So initially the data given is length of the crank or radius of the crank is given as 150 millimeter, that is equal to, convert that into meter, that is 0.15 meter. Then length of the connecting rod is also given 600 millimeter, so that will be equal to 0.6 meters. Theta is given 30 degrees, that is the angle which the crank makes with the inner dead center is given as 30 degrees. And the crank rotation speed is also given, that is 100 rpm, which is the constant speed with which it is rotating. So now solution. Initially let us find out the angular velocity of the crank. Angular velocity of the crank is given by, that is omega is given by 2 pi n by 60, so that is 2 pi into 100 divided by 60. Therefore omega is equal to 10.472 radians per second. Now we need to find out the ratio of the connecting rod length to the crank length, that is n is equal to L by R. So 0.6 divided by 0.15, that is equal to 4. Now we know that from the derivation we have obtained the formulas for the velocity of piston, that is Vp, V suffix p, omega into R into sin theta plus sin 2 theta by 2n. So this is the equation which we have derived yesterday in the last video. So substitute the values here. Omega we know 10.472 into R value we know 0.15, theta is 30, so 2 into 30 60 divided by 2 into 4. So directly you can obtain the value for this. 10.472 into 0.15 sin 30 plus sin 60 by 2 into 4. So the answer is 0.9554 meter per second. So this is the velocity of the piston. Now let us find out the acceleration of the piston using the formula which we have derived in the last video. So we know the formula for acceleration of the piston, that is omega square into r into cos theta plus cos 2 theta by n. So substitute the values here. 10.472 into 0.15 cos 30 plus cos 60 by 4. So calculate the acceleration of the piston. 10.472 square to 0.15 to cos 30 plus cos 60 by 4. So the value is 16.3 meter per second square. So this is your acceleration of the piston. Now he has asked us to find out in the question, it has been given to find out angular velocity of the connecting rod also. Angular velocity of the connecting rod. So angular velocity of the connecting rod is given by the formula omega into cos theta divided by n. So substitute the values here. 10.472 into cos 30 divided by 4. So therefore omega c is 2.267 radians per second. Now in order to find out the angular acceleration of the connecting rod, we have the formula alpha c or alpha suffix c, that is connecting rod, is given by minus omega square by n into sin theta. So substitute the values here. Minus 10.472 square divided by 4 into sin 30. Therefore alpha c is equal to minus 13.708 radians per second. So this is a very simple problem which has been solved by using the equations which we have derived in the last video. In the next video we will discuss about the loop closure equation.